This is organic analysis. When identifying organic compounds, we need to know what the functional groups are before we're doing this. And we're going to look at some chemical tests to work out what the functional groups are. We need to know all the organic chemistry studied in your A-level course before we look at this. We're just bringing it together here now. Some tests are very straightforward. So before you start thinking about how to identify functional groups, have a think, ask yourself the question, is the compound acidic? So if it's acidic, it might be a carboxylic acid. That might not need a chemical test. Perhaps the compound is a solid. If the compound is solid, it might suggest that the carbon chain is long. Be very long indeed, actually. Or that it has some ionic bonding in it. Perhaps a zwitter ion of an amino acid. Or if it is liquid, that suggests that the carbon chain has a medium length. And that the forces between the molecules are not quite as strong as ionic bonding, but perhaps the has some polar groups in it, or there's some hydrogen bonding between the molecules. For example, a carboxylic acid has hydrogen bonding between the molecules. Or if it's a gas, that would suggest that the carbon chain might be small. Or the chain has little or no polarity. You might want to ask yourself the question, does it dissolve in water? If it dissolves in water, that would suggest that it has polar groups. For example, a C double bond O. If it does not dissolve in water, for example, if it dissolves in a non-polar solvent, for example, for hexane, it would suggest non-polar groups. When you burn it, has it got a smoky flame? If it has a smoky flame, it might be aromatic. Because you've got a high carbon hydrogen ratio. If it is a non-smoky flame, what we'll call a clean flame, that would suggest that it's not aromatic. And that is because we have a carbon-hydrogen ratio which is low. Let's have a look at some specific chemical tests now. So we're going to take just some of our functional groups. So you've got to know how to test for an alkene. So an alkene, the test is to shake with bromine water and the red-brown colour of bromine water will disappear. It will go colourless. If we have a haloalkane, the first thing that we need to do is to add sodium hydroxide and warm it up, sodium hydroxide solution, and warm it up. And the reason why we do that, if you want to make a note of this if you've forgotten, and that is the haloalkane can turn into an alcohol
by a nucleophilic substitution reaction. The next thing we do is we acidify with nitric acid. So all of this, remember, has been covered in previous topics. And then we add the silver nitrate solution. And we get precipitates. If we remember, if the haloalkane contained chloride ions, we'd get a white precipitate. If the haloalkane contained bromide ions, you get a cream precipitate. And if the haloalkane contained iodide ions, you get a yellow precipitate. Now, you need to know the other test, which you can use to confirm this, and that involves ammonia, so please look that up now and write that down. We can test for an alcohol as well, and we can use acidified potassium dichromate for that. And what happens then is the potassium dichromate is orange, and we know that if the acidified potassium dichromate reacts with that alcohol, it turns green. This would be an oxidation reaction because the alcohol will be oxidized. So if we are oxidizing the alcohol, then the acidified potassium dichromate will in turn get reduced. Now this will only work with a primary and secondary alcohol or an aldehyde. To test for an aldehyde, again, we could use acidified potassium dichromate, or we could warm with Fehling solution. Or warm with Tollens. So if we're warming with Fehling solution, the blue turns to a red precipitate. So it goes from a blue solution, so that's what colour Fehling's is, to a red precipitate. If we are using the acidified potassium dichromate, we know here that the orange colour goes to a green, and we know that the Tollens reagent is otherwise known as the silver mirror test. We get a silver mirror that forms. Please don't get mixed up between Fehling's and Tollens. Fehling's, blue solution to red precipitate, Tollens, silver mirror forms. So it's Tollens silver mirror test.